So you're saying segment CE. So you said this is 8, so this is 8? Okay. So that's a good start, but remember that these are similar triangles, so they're not congruent, meaning that they're not the same, okay? So you have to set up a proportion so that parts match with parts. So it says this part right here, can everybody see that? Matches with this part right here. Can you see the two different colors? Kind of, sort of. So we need to match up the bigger triangle, which is 10, with the smaller triangle, 5. Okay? So the bigger triangle as a top, and the smaller triangle we don't know. So what would we do here? I'm sorry, before I move on, are there any questions so far? Okay, so what would we do here? This is a proportion. How do we solve proportions? Cross multiply. So we're going to cross multiply. We have 10x is equal to 40. How do we solve this? Divide by what? 10. X is equal to 4. Questions? But have I solved the entire problem? What is it asking me for? It's asking me for this whole segment. We only solved for this segment. So then what's the entire segment length? 12. Good. That's the correct answer. Questions? Questions? Okay. Next one, asks me to graph, so we need points, and label the intercepts. This is in standard form. You all worked with standard form last year? No? Yes? Maybe so? Okay. Who can tell me what the definition of a y-intercept is? Anyone? I always get that. That is the equation of a line. You can find the slope, the intercept using b. Where does the y-intercept cross? Y-intercept crosses where? Y-intercept crosses where? Ms. Ravello, you want to call in a letter or a number or color?
Purple to B.
Who's purple to? What does the y-intercept cross on a graph? Gentlemen. All right. We're going to pause here. Seniors, we're not going to get better at math if we don't try, if we don't ask questions. And if you don't know, it's okay. That's what I'm here for. Okay? That's what we're here for. Me and Ms. Ravello. The y-intercept crosses the y-axis. The y-intercept crosses the y-axis. What would the x-intercept cross then? Yes, I heard somebody whisper it. Was that Vega? The x-axis. Okay? So we're going to take a break from this right now. Tomorrow, we need to be on top of it. Okay? I'm going to give you the answers really quick. I will give you the answers really quick. So the y-intercept is 0, -3. Write this down. The x-intercept, you can't see. The x-intercept is 2, 0. Wait, I'm sorry. Wrong way. I need white out. Awesome. This is -2, and this is 3. Sorry. And plot those points, -2, 3, and connect them. Next one. The answer is 5. You needed to set up an equation. 4x plus 12 equals 8. Solve for x. X is equal to -1. And then create another equation where it's 2 times -1 plus 7 equals 5. Mr. Vella, can you make sure everybody's writing this down? Did you take a pen? You took a pen? Yeah. Okay, Daisy's on her way. No. What did I do wrong? Can you see, or do I need to zoom in?
What?
Do you need me to zoom in?
No.
Okay. All right, the next one is B. I'll explain that tomorrow. We'll have another problem like that. And then the last one is A. I explain that one tomorrow. We'll have another problem like that. When you're done, put this away. Take out your notebook or a piece of paper or whatever you're doing to capture notes. Ms. Ravel is going to pass out the example sheet for today. Can I have one? If you don't have a notebook or paper, in the bin where the do now is, under the last, or in the last shelf, there's a bunch of paper. So please make sure you grab some. You're going to need this. If you need any supplies, please reach out to any of us so that this way we can figure out how to get you those supplies, because you will need them for class. Okay. How class is going to run, for the most part, is on days that we're learning. Let me stand up so you can see. On days that we're learning new material, I'm going to present you with notes. We're going to go over those notes, the vocabulary, notation, and then we'll go over some examples, okay? So, no. Justin, you okay? You need some water? Okay. And then we'll have practice, okay? The day after new material is given, we'll have practice in class and then have an exit ticket at the end. So tomorrow we're gonna have an exit ticket. It's gonna be a 2-question exit ticket. It's not that long. And then our first real quiz, thank you, and assessment is next week, okay? I'll let you know exactly what day. We will have days where we're pausing instruction. I'm sure Ms. Eckberg did this, where you're pausing and you're leveling up, getting help, making up any missing assessments. But we're gonna have 2 grades in this class for now: the calculus grades and then the SAT grades. Okay, the SAT grades are only for quarter 1 until the SAT is taken. Are there any questions on how that's gonna work? Okay. So everybody should have their notebook out. What you're gonna do is you're gonna label it. You'll see what I'm gonna do. You're gonna label it with today's date, and then also the name of the lesson. So this way, when I say, hey, go back to where we're talking about limits or derivatives or this, you know where in your notebook or folder or binder those materials are. Oh, sorry, one more thing. All of quarter one, you're going to be allowed to use your notes, your worksheets, anything that we have had in class on your assessments. Quarter two, we're pulling that away, and I'll let you know what that's going to be. Okay? Got it? All right. So today is the 27th, and please let me know if you can't see so I can zoom in. Today's the 27th. We're going to be talking about limits and their definitions. Limits and their definitions. Stop me if I'm going too fast, raise your hand, tell Ms. Ravello, okay? If you can't see, because my head's gonna be down most of the time writing these notes and I can't see you, okay? All right, first definition we have is limit. The limit of a function is the value, meaning some number or variable. Also, if I'm off screen, please let me know. Of a function or graph as the x value gets closer or approaches, oops, did I spell that right? Yeah. Some number. Now I know this may not make sense right now, but we need the definition before we actually get into the examples. We have specific notation, just like anything in math. We don't like to write tons of letters and numbers and, words, so we create notations for it. The notation is as follows. LIM, this stands for limit. As x approaches a of f of x is equal to b. And I'll explain what all this means in a second. Ms. G, I think I forgot to write this on that. Okay. When we're speaking in math, we don't say exactly what this is. We don't say lim x arrow a f period f parentheses x parentheses equals b. We don't talk like that in math. We don't speak like that in math. That is not correct mathematical vocabulary. So when we get new notation like this, what I'm going to do is I'm going to put underneath it how we read it in math, okay? So in math, we read it as, so it's read as the limit, and then I'll write underneath what it means, limit. So that's what this is, lim. Am I going too fast? Anybody? Okay, a little bit. The limit, so LIM, stands for limit of, excuse me, thank you, f of x. This is not f parentheses x parentheses, f of x as x approaches, so gets closer and closer to, A, x approaches A, is equal to B. So equal B. When you're done writing this down, can I get a thumbs up so this way I can get a gauge on who's done, who's not? Okay. Once you put your thumb up, you can put it down. I just want to make it clear. Okay. I see a couple more people writing, that's fine. Yeah. We good? Okay. Before I forget, I'm gonna try to make sure that I post the lessons, the lectures on YouTube, so that this way you have them if you miss something or if you're out a day. I may forget sometimes or it may not work. Okay? So if you miss something or if I'm going too fast or need a refresher, go on to YouTube. I'll post it on Google Classroom so this way you have it. Okay? For reference, A and B can be numbers, or we're going to see soon, we're going to see something that's called does not exist. And we'll talk about that in a second. Or it could be positive or negative infinity. So A and B can be numbers, something that's called does not exist, or positive and negative infinity. We'll get to what all these mean later. I just need to give you all of this information so that when we get to it, I can refer back to what I was talking about. Can I move this up so people can see? Is that good? No? Do I need to go back down? Seniors, is it okay to talk, to say yes or no, to shake your head? Okay. We've got a few more definitions before we get into our examples. Okay? We have something called the point of discontinuity. Point of discontinuity. The definition of a point of discontinuity is the point on a graph or the value of a function where the function, am I off screen yet? Is undefined, which means it has no value. And what this means is it does not exist. This last thing is really important for limits. Like really, really important. So underline it, highlight it, star it, whatever. In order for a limit to exist, meaning that it has a value, we can find a specific number it's getting closer and closer and closer and closer to. Okay? For a limit to exist, both parts, meaning the left and right side, of a graph or function must reach the same number. Am I going too fast, Mr. Vello?
No, but can you scoot up?
Oh, yeah. Even if there is a hole, meaning a point of discontinuity. I'm going to abbreviate that to be point of discontinuity. Okay. Okay. I know that was a lot, but we're done with notes. We're going to move to our examples. So then, when you are done with that, take out the example sheet that Ms. Ravello passed out. This thing that you passed out. It says student printout at the top. Should have today's date on it. Just in case somebody needs to catch up. You can leave your notes out. You don't have to put them away because we might reference them. Can I get a show of hands when you're done so this way I know I can move on to the example? Okay, 2, 3, 4, 5, okay, 6, 7. Thumbs up, show of hands, doesn't matter. 9, 10. Gentlemen, we done over there? See, this is why I sent you guys over here. Yeah. Does anybody need more time to write that down? Sounds like from all the whispering, we're good. Okay, we should have the example sheet out. In class, you will get, like I said, you'll get notes, and then you'll get an example sheet most of the time, unless, we can just do the examples in our notes. But if it comes with a table or graph, I'm going to print it out for you, so this way you have it, okay? This is why you need a binder or folder and a notebook. Okay. So we're going to estimate limits from graphs and functions, okay? The first thing you want to do, I wish I had more room. The first thing you want to do is find the x value. What is the x value getting closer and closer to? So, find the x value. That's what you want to do. The first thing you want to do is find the x value, okay? So, if we look at this example, I'm going to zoom in so we can see it. What x value, what number is this getting close to? What number is this getting close to? 1. Good. So that means x is going to approach 1, meaning that x is getting closer and closer to 1. Are there any questions on that part? Are we sure? It's okay if you do. If you don't understand the definition, let me know. I'll explain it again. Okay? I'm going to zoom out again so we can find or write the next step. Next thing you're going to do is find the y value. What is your y value getting closer and closer to? Okay? Here, remember y and f of x are the same. Okay? Find the y value. Find the f of x value. So in this example, what is my y value? What is f of x getting closer and closer to? 3. Good. So y is going to be 3. But remember, in our limit notation, this is b. Okay? Let me write the limit notation at the top so you can remember. So it's the limit as x approaches a of f of x is equal to b. Okay? Any questions so far? Are we good? Okay, so now I need to write the limit notation. The only thing that's going to change for now, eventually we will also change 3 things. So we're only changing 2 things for now. So circle, highlight, star the following things that you'll be changing when you write the limit notation. We're going to be changing A and B right now. Those are the only 2 things right now that will be changing when we write limit notation. Again, these are the only 2 things that will be changing when we write limit notation. Questions? Okay. So, we're going to start off with the limit. That doesn't change. As x approaches my x value. What is my x value that it's approaching? I heard somebody say it. Not y, x. 1, good. Are there any questions on that? Because not a lot of you said anything. Or are we just being shy and nervous? Of f of x is equal to b, which is my y value. What is my y value? 3, good. So this, when I ask you to write limit notation, this is what it has to look like. Okay, your table, your x value is getting closer to 1, which is A. And the limit is approaching B3, which is B. Questions? Okay. For sake of time, we're going to skip the next one, and we'll have more examples on this tomorrow. And we're going to go down to here. Okay? We're going to do some graph work. Okay. Thank you. Okay, so let's look at this. Good morning. Let's look at these examples. Thanks. It says for each of these functions, the limit as x approaches 2. So that means that this is going to be my x value. Okay? That will be my x value. That means that your function, your graph, is getting closer and closer to that number. And then this is the number that it gets closer to. Okay? So let's look at it. This is how we're going to find limits. We're going to go from the left side of the graph to the right side of the graph, meaning that we start at the left, and go to the right. But also, we have to start at the right and go to the left. And we need to find that value. I'm going to say it again. We need to start at the left of the graph. It doesn't matter if it stops or ends. We need to start at, you'll see when I do my finger pointing, and go to the right to the value. So So what is the value that I'm stopping at? What x value do I stop at? 2. Good. Who said that? I know I said that. Was that Lucero? Good. We're stopping at 2 because that's where we need to stop. And this is what I like to do. You can do it if you want. It's up to you. I'm going to draw a line where 2 is so I know I need to stop there. Okay? I'm trying to find that value. Does that make sense what I said?
Yes.
Thank you. Thank you for responding. Appreciate it. Okay? So I'm going to start at the left side of the graph. I'm going to trace until I get to that point. And then I stop. Okay? So that's that. Then I'm going to start at the right and go to the left. And that's that. If you circle the same point, excuse me, thank you. If you circle the same point, that means that is the limit. Does that make sense? So if you circle, if that's what you want to do, if you want to circle the same point, that means that that is the limit. So that is why the limit, excuse me, the limit as x approaches 2 of f of x is equal to 4. Questions? So these 3 graphs have that same limit. It's just shown in different ways. Questions? Okay, I'm going to do it on here now. I'm going to go from the left and go to the right. And I stop there. Because here's 2, right? Go to the right. Stop there. Limit is 4. Here's, oops, I just crossed it out. But this is 4. Our limit, our graph gets closer and closer to 4. But I always hear, what about this point right here? What about this point right here? That does not matter, honestly. Sorry. Because your graph is following this line and it gets closer to this point right here. Okay? We'll talk about this later. All right? We'll talk about this later. Questions? Okay. Now, again, we're going to start at the left. So I want to get to 2. We're going to start at the left. We're going to follow the graph all the way until we get to that point on the left. And then we're going to start at the graph all the way until we get to that point on the right. Again, the limit is 4. I'm going to give you some processing time. See if you have any questions. Please let us know if you have questions. Questions? Can you give him the notes, the printout? I mean, the one that I wrote. Questions? Are we sure? Okay. Are we good? Can I flip over? Thank you for your thumbs up. Okay. All right. So now let's look at these. These are where the limits do not exist. That means your function is not getting close to the same number, or any number for that fact. It's not getting close to any number or the same number for that fact. So, again, I'm approaching 2, which is my x value. Right now, even before I'm going to zoom in, sorry, so you can see. Before I even start drawing my lines, you can tell that your graph, the black lines, are not going to any place specific. So if I follow this, it's going up and up and up and up. Because remember, that's what functions do. They continue on forever. This side is going up and up and up and up and up. It's not going to any point in particular. That means the limit does not exist. There is no value of y that your graph is getting closer and closer to. So to write that, I'm going to do this. The limit as x approaches 2. So up here you see that it is the limit as x approaches 2, right? Of f of x is equal to does not exist. This is how you write it for does not exist. Can everybody see that color? I saw some confused faces. Please ask questions, okay? If you're not comfortable asking questions, write it on a Post-it note. Write it on something and give it to me so that I can know that. Do you need me to zoom up? I see you like looking over. Is that good? Can you see that? Okay. Are there any questions on why this does not exist? Thank you. Okay, now let's look at this one. Again, if you can't see the colors, also please let me know. Here's 2. Okay? I'm going to start on my left side and go to the right. Am I going too fast?
No.
Okay. So if I start on the left and go to the right, I get this point. But if I start on the right and go to the left, I get this point. Is the graph approaching the same number? We're not approaching the same number because we didn't circle the same point. Again, it does not exist because we did not circle the same number. The graph is not going to the same point. Does that make sense? Are we sure? It's okay if it doesn't. This is new. This is brand new. Good? Okay. So again, the limit doesn't exist. I'm not going to rewrite it because it's the exact same notation. Okay? Good? Excuse me. Thanks. All right, last one. This one's a little tricky. So I'm going to write my little dotted line for 2. You can write a dotted line. You can do whatever you want. Put a highlight or whatever. Do I have a left side of this function? No. If there are not 2 parts to a function, it automatically does not exist. Because I can't come from the left side to figure out where the function is coming from. Okay? I'm going to put here a little note. Does not exist because part of the graph is missing. Can you see that? Yes? No? Okay. What's wrong? Oh, good? Good now? Okay. Okay? This does not exist because one part of the graph does not exist. It's not there. It's missing. Is that good? I see some of you like looking up. We'll do the second sheet tomorrow. Questions? Okay, now let's get to a very, very good example. Seniors, last year when I taught this, a lot of students had problems with the graph, so I'm going to try to go a little slower for this, okay? Do we want it darker or lighter? Is that better right there? Good? That good? Okay. So this is what a normal calculus graph would look like. This is what a normal calculus graph would look like. We have points of discontinuity. We have jump continuity. Jump continuity means like it goes from one point to another. We have asymptotes. Did you learn about asymptotes last year? Okay, we'll talk about asymptotes later. But first thing you want to see, does this have a left side of the graph? Does this graph go on and on forever on the left side? Yes. There's a little arrow that tells me it goes on and on forever. Is there a right side of the graph? Does that go on and on forever? Yeah. These arrows, remember, tell me that they go left and right forever. Okay? So let's look at the first one. The first one asks me for the limit as x approaches -2 of f of x. So what value are we looking for x? What value? Or -2. So again, if you want to draw this, can you see the graph? Do I need to zoom in? How's that? Do I need it darker or is that good? So I'm gonna go, where do I start, left or right? Okay, we can start with left. It doesn't matter really. Just as long as you know you have to go from both sides, okay? You have to go from both sides. So I'm gonna start here and I'm gonna go here and stop, okay? Now, a lot of seniors or a lot of people think that, oh, well, I can't get there. So if I start at the right, I can't get there at all. But remember, these continue on forever, so you can jump things, okay? So I'm gonna go from the right, go to the next part of the graph. Am I going too fast? Okay, jump up here. As long as your graph gets to that point, I'm not gonna trace it because then it'll be too many colors, but then I go here. Has the graph reached the same point? Did both sides, good. I see a lot of your head nodding. Yes, your graph has reached the same point and you've circled the same point. It's okay to estimate, so I'm gonna estimate there at about a half, okay? It's okay to estimate. So the limit is 0.5, or if you wanna do fractions, 1/2. Questions on that? We're gonna stop in like 2 minutes so that we can put our calculators away. Questions? Okay, so what point am I going to next for B? What x value? 3. We're gonna go to 3, okay? So, I don't see a 3 here, like on here, but I see this 3 point here. So I'm gonna draw a line through the 3. And now I'm gonna just go from my left side, here, and my right side, here. Did I do that too fast? Okay. Oh, I heard somebody say what? I don't know if that was for me, so I'll just repeat myself. I'm gonna go from the left side until I get to the 3, and the right side until I get to the 3. What is the y value? Well, first of all, does the limit exist? Does it get to 1 point? Yeah, I see head nodding. Good. Yes, it exists. What is that number that it exists to? What is the value? -1. Very good. -1. Questions? You good? Okay. I'm going to do one more for sake of time. Does that one? Yeah. Okay, that one does not exist. And I'll show you why. All right, let me zoom into the graph. All right, come on, autofocus. All right, okay. We're looking for the limit as x approaches 0. Remember, 0 is your axis, so this is my axis here. Can you see the color? Okay. I'm gonna use a highlighter this time. So I'm gonna go for my left side, and I'm going to stop on the axes. And then I'm going to go on the right side and stop on the axes. What is the limit? Someone said 1. Someone's shaking their head no. Someone said 3. I heard does not exist. Why doesn't it exist? That is the correct answer. Why does it not exist? Good, they're different points. You circle 2 different numbers. Even though this side got to a number, even though this side got to a number, they're not the same number. They have to be the same number. Is that clear? Yes. All right, yeah, you got it now? Yes, so this does not exist. Because, and I'm going to write a rationale, because, excuse me. Thanks. Somebody's perfume is making me sneeze. The function, I'm just going to put f of x, does not, can you see? Approach or get close to the same number. Okay. Just so you know, I probably won't be assigning homework unless we have an assessment the next day and you didn't get through all of your classwork. So there is no homework, but tomorrow we're going to have practice and an exit ticket, okay?
Yes.
When you are done writing this down, put your stuff away. We'll go table by table to put your calculators up.